All right, I want to show you guys the recursive for quadratics quick. All right, let's take a look at number 2. You guys have had this already, but let's just go ahead and take a look at it. We're going to first identify our changes. Okay, so I'm going to have my first difference and my second difference. Well, -5 down to -7, I'm going to subtract 2. -7 back up to -5, I'm going to add 2. -5 to +1, I'm going to add 6. And 1 to 11, I'm going to add 10. Now I'm going to take a look at these differences, see if I can get something that is consecutive. -2 up to +2, well, I'm just adding 4. +2 to +6, I'm going to add 4. And then +6 to +10, I'm going to add 4 as well. So my second delta, my delta squared, is going to be the addition of 4. I know that my a value, okay, remember our function is ax squared plus bx plus c. My a value is this number divided by 2. Okay, so a is 4 divided by 2, so I'm going to get 2. My b value, we don't know, we have to solve for that, and c is going to be my y-intercept at -5. So -5. Now I have these values. I'm going to go ahead and plug them in to find my b value. So I have 2 is my a times a number plus b times a number minus 5, okay? In here, I'm going to use 1. I'm going to pull this 1 out from here and plug that in for x. Next, I need to know what my answer is to this equation when x equals 1. And in that case, it's my y value, and in this case, it's also 1. So, what's 1 squared? 1. And then we have 1 times 2. We get 2 plus 1b, because 1 times b, minus 5. Combine your like terms. 2 minus 5 gets us -3 plus 1b. All right, and then add this to both sides to get that b by itself. I get b equals 4. Okay, this should be review for you. All right. So I know that my b value is 4. This is how, and my function is going to be f of x equals 2x squared plus 4x minus 5. Okay, I'm just plugging in. So this is my function, my explicit function for quadratic. Now I want to find the recursive function. We're going to set it up just like we did before. We have f of x. All right, equals, well, what does it equal if x equals 0? Okay, I go up here, x is 0, my y-intercept is -5. That's my CAN language, okay? My next number is going to be, okay, it is going to be whatever this second change is, okay? So in this case, my constant second difference is 4. So my CAN language I first should start by is f of x minus 1, okay, times this number, and then x is greater than 0, okay? All right. So I want to go ahead and figure out what, okay, there's going to be a plus sign right here. I need to figure out what goes here, and that is how I find my differences. All right, my second difference is 4, okay, so it's going to be a number times, x, okay. In this case, it's 4x, because I'm going to have 4x. So I'm going to plug that 4 in. This is my second difference. And then I need to add to it a number to get my first change, okay? So what that looks like is I take my x value, okay, which is -2. I'm going to multiply that by that 4, okay? So I'm going to do it right above here. So I have -2 times 4, which is -8. But I need to get it to -2, okay? So what do I need to add? I need to get it to -2 because that's my first change. What do I need to add to that 8 to get it to -2? And that is going to be +6, okay? So it's going to be 4x plus 6. And that is what's going to go right here, okay? How we can test that out, so this would be done, okay? How we can test this out is we can go ahead and just plug it in. So I want to see if I take this 4 times -1, will I get this +2? So -1 times 4, because that's our value right here, okay? So I'm just plugging in -1 for x and 4. All right, and then I'm going to add 6, and I should get this 2 right here. So what's -1 times 4? Well, that's going to be -4. Add 6, and that is going to get me +2, which is the same right here. So I know that this is my recursive function. Okay. All right, let's go ahead and I know that was kind of a lot. Let's go ahead and take a look at another one. I have the explicit function for this table right here. Okay, so delta squared. Okay, this is going to be subtract 13, subtract 7, and then subtract 1, and then I'm going to add 5. My constant second difference is going to be +6 all the way down, okay? My A value is going to be 6 divided by 3, which gets me 2, okay? B, we don't know, and then C is going to be my y-intercept, which is 0, okay? I am going to do this on my whiteboard so I don't get it confused, okay? I plug in my A value. So I have 2 times x squared plus b times a value plus my c value, which is 0, okay? I'm going to use this 1 right here, so plug in 1, and then my answer when x is 1, y is -1, okay? So this is going to be -1 equals 2 plus 1b plus 0, combine like terms, I get -1 equals 2 plus 1b minus 2 from both sides. I'm going to have -3 equals b. Okay. Go ahead and plug that in. Rewrite your function f of x equals 2x squared minus 3x plus 0. Now I need to find my, my recursive. So remember, this is can language, f of x equals blank if x equals 0. And then my can language would be f of x minus 1 plus something if x is greater than 0. Okay, this is your can language. So we need to fill in this and this. Well, what is my y value when x is 0? Well, in this case, it's 0. Okay, now I need to figure out this. So I know I'm going to have an x here. Okay, this number right here is just going to be my second difference. So I'm going to put that 6 there. Now I need to figure out how to get my 6 times my x value to equal, in this case, -13. Okay, so we have 6 times negative 2, because I'm pulling that from that x right here, and it should equal negative 13, okay? Well, what is 6 times negative 2? Negative 12, okay? Does that equal negative 13? No, so I need to do one more thing to get from negative 12 down to negative 13, and that is subtract 1, okay? So this would be my recursive. Okay, good luck.